guys, Jennifer here from Jenkinson's Aquarium, and today I wanted to talk to you guys about how ocean acidification, which is one of the effects of climate change, can affect some of the animals that live here along our coast. So first off, let's talk about climate change. So what is climate change? It's the change of our climate over long periods of time, and it's currently being driven by something we call excess carbon dioxide. So when we burn fossil fuels like oil and coal for energy, we release carbon dioxide into the atmosphere. This excess carbon dioxide can do all sorts of things. It can trap heat and change the chemistry on our Earth. Now, the ocean is an amazing thing. It's called a carbon sink. So what that means is it can absorb a lot of that excess carbon dioxide. In fact, it absorbs up to 25% of what we produce, and that equates to about 2.4 billion tons a year. So that's a lot of carbon dioxide. The problem is, as it absorbs this extra gas, the chemistry of the ocean begins to change. We start to see things like calcium carbonate, which is a building block for a lot of invertebrates, decrease. And we're going to get to meet some of those animals today and talk about how it affects them. So the first animal I want to introduce you guys to is an animal that is a gastropod. So as you guys remember, you're invertebrates. What that means is this guy has a single shell. The shell is usually built in a really beautiful spiral fashion, and we think of them as univalves. Now this guy here is actually a channeled whelk, and they get their name from this cool channel that runs along the entire spiral of their shell. So the way that they make this incredible feature is they actually start off about the size of the tip of the shell, and year by year they're going to lay down layers of calcium carbonate. Almost like the way a tree grows, or think about growth rings on a tree. And they're going to kind of grow year by year by year until they get this large or even larger. So as they lay that shell down in layers, it helps protect them. So these guys here are soft-bodied, so they're kind of squishy. If you guys notice, he actually has this kind of circular thing here. We call that an operculum. Think of that like a trap door. So you can actually pull that in, close inside, and help protect him from animals and other predators. And then the rest of this part here is kind of his foot or his tissue. So the way that these guys are affected by ocean acidification has to do with their actual shell. So I want us to start thinking about it as osteoporosis of the sea. So when we get osteoporosis as humans, our bones can become much more brittle, much more fragile, and much easier to break. When animals in the ocean suffer from osteoporosis of the sea, their shells become much more fragile, much more brittle, and much easier to break. And that would be something that could happen with an animal like this. So these guys don't have enough of that building block to create their shells, and it can cause them a lot of problems. Now, how does that affect us in the long run? Well, an animal like this shell, like this channeled whelk, is actually a really important food source for other animals in the ocean, like blue crabs. Now, blue crabs aren't just important to the ecosystem, but they're also important to our economy. Blue crab fishing is a really big deal, not just here in New Jersey, but all up and down the East Coast. So if we were to lose these animals, we could actually lose a really big source of income and jobs for many American families. That could be quite a big deal. So we're going to go ahead and put him back, and I'm going to introduce you guys to my next animal. Now, my next animal is one you're definitely going to recognize. He's pretty popular. He's a very cool looking animal, and that's this guy right here. Now, this guy here is a common sea star. So some animals, like my channeled whelk, are going to build their shell on the outside. This guy uses calcium carbonate to help build some of his internal skeleton or internal structure. Now, this guy here actually has ridges and bumps on the outside, and some of that is formed from that calcium carbonate. Now, he has a hydrostatic system. So what that means is if we keep him out of the water for too long, he can actually drain, and that can cause him a lot of stress. So we're going to put him back. But he's really important to the ecosystem because he's a very important part of the food chain. So he actually is food for many animals like other sea stars, birds, and even sea turtles. And then he in turn is a predator as well. So he'll eat sea turtles, or not sea turtles, sea stars and other clams and bivalves. Now, the last animal I want to introduce you guys to is probably one of the coolest invertebrates that I've met. So he's actually called a sea urchin. Now, this guy here is a purple sea urchin. Now, for the most part, sea urchins are vegetarians. So they go along the bottom, they kind of munch on the algae, although they can sometimes eat something like a kind of a dead barnacle they might munch on or something like that. Now, these guys have a very interesting challenge when it comes to ocean acidification. So what they'll do is they have a very difficult time maintaining their internal chemistry as a result of the changing ocean chemistry. And they'll start to dissolve parts of that internal structure in order to make everything even and create homeostasis. Now, if you guys have ever tried to find a sea urchin cast on the beach, you'll know it's incredibly difficult. These are really, really fragile. So they don't really have a whole lot to give if they start to deteriorate this portion of their body. So it's really important for them to kind of maintain that stasis. So it's not a good thing when they have to start breaking down their internal shell in order to survive. So I'm going to go ahead and put these guys back. I hope I gave you guys a little bit of insight into how ocean acidification is affecting our local animals, and I hope you guys have a fantastic day.